Okay, we're doing logs and exponentials. You may not use a calculator. You know how we always have part A and a part B test? Welcome to part A test without a calculator. Yeah? Yeah. Okay, so do you see your two bases? You have a base of 4 and you have a base of 2. I need them to match. Obviously, I cannot change 2 because it's as simple as it can possibly get. So I have to change 4 to become a base of 2 to a power. So what is 4 as a base of 2? 2 squared. So this is going to become 2 to the, write the right thing. 2 squared to the x is equal to 2 to the x plus 3. Now, when you have a power raised to a power, what do you do with exponents? You do multiply them. So this is 2 to the 2x is equal to 2 to the x plus 3. So now that my bases are the same, what can you conclude? They can cancel out, and you have 2x is equal to x plus 3. How do I solve this? Subtract the x is equal to 3, but bam, we're done. No calculator, simply algebraic manipulation. What do we not like about that, sir? Huh? 2x minus x is 1x. No, that's just solving equations, bud. 2x equals x plus 3, right here? We're talking right here? Yeah, just simply subtract x on both sides. We good? Okay. All right, number 6. What do you not like about this problem? There's a fraction. I don't like the fraction either, so how can we change that? First of all, before I change that, I'm going to take and say, hey, this has a base of 10. This has a base of 100. Can I rewrite 100 differently? What is that going to be? 10 squared. Okay, so this is going to be 10 to the 2x plus 4 is equal to 1 over 10 squared raised to the x minus 3. But it's in the denominator, and I don't want it in the denominator, so how do I move it to the numerator? Absolutely, make that have a negative exponent. Correct? So now, what do I do with exponents whenever I have a power to a power? Multiply those. However, you have to make certain that you are distributing that. So that's going to be a negative 2 times an x minus a 3. Yes? So now my bases are the same, so I can set my powers equal to each other. So 2x plus 4 is equal to negative 2x plus 6. Yes? Add 2x. So 4x plus 4 is equal to 6. Subtract the 4. 4x is equal to 2. Divide by the 4. X is equal to a half. Yes? Zane, are you good? Okay. May I move on? Okay, number 12. This is a logarithm. Our brains don't think in logs. What are our brains thinking? Exponentials. So what is this thing equal to? You don't know, right? So you're going to set it equal to x. And you're going to write this as an exponential. 10 to the x is equal to 0.0001. What fraction equivalent would 0.0001 be? 1 over 10,000. Now, there's a couple ways you can do this, and I don't care how you do it. But the really smart, easy way is to go 1, 2, 3, 4, and use scientific notation. So I'm going to move that 4 times to the left to make that a smaller number, so that's why it's 10 to the negative 4. Does that make sense? Right? Scientific notation? We all good with that? If your brain does not like that, what you can do is make that 10 to the x is equal to 1 over 10,000. And then your brain can understand that to be 10 to the fourth to make that 10x is equal to 10 to the negative 4. It's exactly the same thing no matter where you go with it. Yes? So then x has to equal negative 4. Yes? Do we all understand? Again, you will be having this part as part A test with no calculator, so you need to make sure you understand these. Okay, next. Do it. Set it equal to x, so you're going to have a 1/2 to the x is equal to 128. What is 1/2 actually? It is, so that's 2 to the negative x is equal to, well, what's 128? So that's going to be 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128. So 2 raised to what power is 128? To the 7th power. So negative x is equal to 7, so x is equal to negative 7. Yes? $16. What's it equal to? Yep. So I'm going to have the square root of 3 raised to the x power is equal to 27. How do we rewrite the square root of 3? Does anybody remember this? Okay, I'll give you a hint. Power over root, the power is 1. The root is understood to be a 2, so this is 3 to the 1/2 x is equal to 27. Remember? So how do I rewrite 27? It is 3 to the third. Very good. So this is 3 to the 1/2 x is equal to 3 to the third. So 1/2 x is equal to 3. So how do I get rid of the 1/2? Multiply by 2, so x is equal to 6. Do it. While you're doing that, listen up. Monday and Tuesday, we're doing end of course testing for Algebra 1 and Geometry, so there will be no periods 1, 2, and 3, or 7, 8, and 9 for me. I'll probably have 9th, but I will not probably have 1st, 2nd, 3rd, or 7th and 8th. Do we all understand that? So Monday and Tuesday, you guys will have no additional homework. On Wednesday, whenever I get back, you guys will have more work. You will go to your labs during this class period. Yes? Okay, so this is set equal to x. So 27 to the x is equal to 9. So how do I rewrite 27 and 9? 3 to the 3x is equal to 3 squared. So 3x is equal to 2, so x is equal to 2/3. Yes? We good? So what do you think? Set equal to x. 1,000 to the x is equal to 10 to the 12th. What is 1,000? Is it? 10 to the 3x is equal to 10 to the 12th. So 3x is equal to 12. X is equal to 4. Six. How do I write this? X to the 4/3 is equal to 81. How do I get rid of a power of 4/3? Okay, well, let's take this out of power of a root. What? How about we make this x to the power of 4, and the cube root of that is equal to 81, correct? Because isn't that what it is? Isn't that what it is? So how do I get rid of the cube root? Yep. So if I cube this, does anybody want to take 81 cubed? No. So you're not going to do that yet. That's just going to be some big number. How do I get rid of the power of 4? Take the 4th root. So can I take the square root of 81? What's the square root of 81? 9. What's the square root of 9? You just took the 4th root of 81. So if you take the square root twice, that gives you the 4th root. So x is equal to 3 cubed. Now what is 3 cubed? 27. But bam, right? Make sense? The 4th root is the square root twice. The square root of 81 is 9. The square root of 9 is 3. Yes? Okay. Hello? Yes. Okay, so I'm going to have the square root of 3 raised to the x is equal to 1/9. Do I like the way the square root of 3 looks? So what is that going to be? What? 3 to the 1/2 x is equal to? Three to the negative 2, because 1/9, 9 is 3 squared, and that's in the bottom, so to move it to the top, it's going to be 3 to the negative 2. So 1/2 x is equal to negative 2. So to multiply both sides by 2, and x is equal to negative 4. Make sense? Yes? Yes, sir. Yes. I'm sorry. The right side or the left side? 28 or 26? Or 28? No, you can't square that because this right here is the square root of 3. You have to get the bases to be the same before you can do what you're going to do. Does that make sense? Because you can't just say you're going to square this, because if you square 1/9, that's going to give you 1/81st, which is a totally different concept. It's a different number, right? Now, technically speaking, technically you could, because this is still going to be 3 to the negative 4, which is what you would have had anyway. So technically you could, but I'd really like you to get in the habit of getting the bases to be exactly the same on each side before you do that, because the power of 1/2 is the same thing as squaring both sides. So I guess that would work. Yes? Me? Okay. That would work. Most students aren't going to want to go there, though, and I really want you guys to get used to that same base. But if you square both sides, it will get rid of that, and it still acts as the power, so I would say yes, you can do it. Okay? I've had a lot of interruptions during this today. Sorry, guys. Okay. So 5 is my base. My exponent is 3. 2 to the x plus 5. 5 times 5 is 25. 5 quarters in your hand is 125. Subtract the 5. 120 is equal to 2x. 60 is equal to x. Yes? Make sense? And the last one I'm going to do. This is going to give you x cubed to the 2/3 is equal to 64. What happens to the cube and the cube root? They do cancel, and you're just left with x squared is equal to 64. So how do you solve that? It's going to be plus or minus 8. Why is it plus or minus 8? Because whenever you take the cube root, you can have the cube root of a negative number. Yes? Any questions? Excellent. Make sure you finish this for homework, yes?